In the hidden world of military innovation, a new era is dawning, one defined by the manipulation of electromagnetism, light, and unimaginable speeds. For centuries, humanity has sought advantage in conflict, but now, science fiction is rapidly becoming battlefield reality. Join me as we explore the United States military's most advanced research programs, technologies poised to redefine global power and security. These are not mere upgrades, but paradigm shifts, silent hunters, invisible shields, and weapons that challenge the very nature of warfare. We'll peel back layers of secrecy to reveal the science, strategy, and implications of these unseen weapons. Prepare for an eye-opening journey into the relentless march of human ingenuity in the pursuit of ultimate security. In a naval testing facility, we witness a revolution in warfare: the electromagnetic railgun. Unlike traditional cannons, the railgun uses a surge of electrical energy to launch projectiles at hypersonic speeds. Two parallel rails unleash millions of amperes, propelling a metal slug with the Lorentz force. There's no explosive flash, just a blinding arc and a crack like thunder. The projectile exits at Mach 6 or more, relying on kinetic energy alone to devastate targets. Imagine warships firing solid slugs over 100 miles with pinpoint accuracy. Challenges remain, the rails erode with each shot, and only the largest ships can house such power. The cannon's era may soon end, replaced by this silent electric titan. Fleets could engage from beyond the horizon, the crackle of electricity replacing the roar of gunpowder. The age of electric warfare is here, and it's only the beginning. For centuries, we dreamed of harnessing the power of light as a weapon. Today, that dream is reality with the Laser Weapon System, or LAWS. Unlike railguns, lasers project pure energy at the speed of light. No arc, no travel time, just instant impact. The effect is surgical. A focused beam burns through metal, detonates warheads, or disables enemy sensors with silent precision. On warships like the USS Ponce, lasers offer revolutionary defense against swarms of drones or fast boats, threats too numerous or nimble for missiles or guns. The cost per shot? Less than $1, powered by the ship's grid, with an almost limitless magazine. Lasers create a near inexhaustible shield, silently neutralizing threats in seconds. But challenges persist. Rain, fog, and dust can scatter the beam, reducing range and power. Overcoming this requires adaptive optics that adjust the beam in real time. Miniaturization is advancing. What once filled a building now fits on trucks or armored vehicles, protecting ground forces from drones. Lasers can also dazzle, blinding enemy sensors or satellites without destruction, offering new, less lethal options. The psychological impact is profound. Adversaries may not realize they're under attack until it's too late. A drone falls, a missile veers off, a boat's engine erupts, often without a sound. This silent, invisible threat disrupts enemy confidence and operations. In a test, the laser silently locks on, a glow appears, smoke wisps, and the target tumbles from the sky, all in under 10 seconds. The laser's speed, precision, and cost-effectiveness are changing the face of defense. As technology advances, lasers will become more powerful, mobile, and versatile. They promise to reshape the battlefield, offering commanders new tools for both offense and defense. The era of directed energy weapons has arrived, and it's only getting brighter. Lasers are no longer science fiction, they're a strategic reality. The future of warfare is silent, swift, and powered by light. The battlefield will never look the same. Welcome to the age of laser warfare. In the race for strategic dominance, speed is everything. Enter hypersonic weapons. Traveling at over Mach 5, they shatter the old rules of missile defense. Hypersonic glide vehicles, HGVs, detach from rockets at the edge of space, then maneuver unpredictably, evading radar and interceptors. Their agility makes them nearly impossible to track or stop. By the time they're detected, it's often too late. Hypersonic cruise missiles, powered by scramjets, fly low and fast, hiding from radar and striking with little warning. These weapons can be launched from air, sea, or land, giving them unmatched tactical flexibility. The engineering is extreme. Materials must survive temperatures that melt steel, and guidance systems must function inside a plasma sheath. The result? A weapon that can strike high-value targets anywhere on Earth in minutes, collapsing the window for response. This creates a destabilizing first strike capability, forcing nations to rethink their entire security posture. The US, Russia, and China are locked in a new arms race. not just to build hypersonics, but to defend against them. Offense now outpaces defense, upending decades of military balance. Hypersonics demand new sensors, interceptors, and strategies, none easy to develop. The offense-defense pendulum swings violently, and the stakes couldn't be higher. Hypersonic weapons are not just faster, they're a fundamental shift in warfare. They force a complete reevaluation of deterrence and global security. The age of hypersonic missiles is here. The world's response will define the next era of conflict. The question is, can anyone keep up? The race is on. In modern warfare, information is power. Enter the stealth drone, a silent observer, sometimes a deadly predator, designed to operate unseen. Unlike familiar drones, these are flying wings, RQ-170, RQ-180, built for low observability, slipping through air defenses undetected. Their smooth, tailless shapes and radar-absorbent materials make them nearly invisible to radar. Engines are buried, exhausts cooled, and noise minimized, reducing their infrared and acoustic signatures. Flying above 60,000 feet, they're out of reach for most anti-aircraft systems. Their primary mission: intelligence, surveillance, and reconnaissance, ISR. They loiter for hours, mapping the battlefield with advanced sensors. High-resolution radars and infrared cameras see through darkness and camouflage, relaying real-time data to commanders far away. This persistent eye in the sky gives unprecedented situational awareness, knowing enemy positions before a single soldier moves. Some stealth drones are evolving into unmanned combat air vehicles, UCAVs, carrying precision weapons in internal bays. Imagine autonomous squadrons striking deep into enemy territory, taking risks no human pilot could. These platforms blend aerodynamics, material science, and AI, representing the pinnacle of modern engineering. They don't tire, don't hesitate, and can operate in swarms, changing the face of air combat. The development of stealth drones marks a new era, unmanned, unseen, and incredibly capable. They are both guardians and executioners, shaping the future of air power. As we glimpse declassified images, we see the future, networked, autonomous, and relentless. The silent observer is now a silent hunter. The battlefield is watched and struck by machines that are almost impossible to find. Stealth drones are the eyes, ears, and sometimes the fist of 21st century warfare. The age of the ghost in the sky has arrived, and it's only growing more powerful. Despite all technological advances, the soldier remains central to the battlefield. But what if we could augment human strength, speed, and endurance? Enter the powered exoskeleton, a wearable robotic suit that works in harmony with the body, amplifying every movement. Lightweight frames of carbon fiber and titanium mirror the wearer's joints, while sensors and actuators respond instantly to intent. Lifting a 100-pound pack feels like 10. Marching over rough terrain becomes almost effortless. Exoskeletons reduce fatigue, prevent injury, and let soldiers carry more, move faster, and arrive ready for action. In logistics, one soldier can do the work of 3, revolutionizing supply chains in the field. The biggest challenge: power. Compact, long-lasting batteries are needed for extended missions. Control is critical. The suit must feel like a natural extension, responding fluidly to the user's will. Full-body suits offer maximum strength, while simpler lower-body versions assist with marching and load carrying. Even passive exoskeletons using springs and clutches can reduce fatigue without power. The soldier of the future may be a hybrid of biology and technology, pushing the limits of human capability. Exoskeletons promise to transform not just what soldiers can do, but how wars are fought. The fusion of man and machine is no longer science fiction. It's becoming reality. The boundaries of human endurance are being redrawn. The exoskeleton is a tool that enhances the human at its core. The next generation of soldiers will be stronger, faster, and more resilient than ever before. The future of the battlefield is human and machine. We've explored the cutting edge of military technology, where physics is harnessed in ways once thought impossible. From railguns to lasers, hypersonic missiles to stealth drones and exoskeletons, the very nature of defense is being rewritten. These are not just weapons, but instruments of power that will shape geopolitics for generations. Each breakthrough sparks new defenses, fueling a cycle of innovation and uncertainty. The future belongs to those who master these new domains of conflict. Which technology will have the biggest impact on global security? The answer is being decided right now, in labs, on test ranges, and in the minds of those who imagine what comes next.